3.1.
Yes,
Quadratic
I am. This
function.
thing is seriously stuck to my hand.
it's all sticky and wrinkly.
It is nature.
Did you take the putty off my desk?
I
And you
didn't.
guys.
My random chance.
Okay, 3.1 quadratic functions. There are. You are going to need your graphing calculator.
Oh no.
Well, you're going to need your graphing calculator, or you can graph quadratic functions by hand like we did last year. Okay, so 3.1 quadratic functions. Let's talk about those for a second.
You're fantastic.
Okay, so what are the three types of forms quadratic functions can be in? Hey, focus. There are three types of forms that quadratic functions can be in. One is standard.
Super Saiyan.
Do you remember standard form for quadratic functions?
Absolutely.
Well, what does a quadratic function have to have with it? What power? Yeah, squared, okay? So standard is ax squared plus bx plus c,
Oh, I remember this.
okay? Then you have something called vertex form, and that's where you have a times x minus h squared plus k. H and K are your vertex. Dakota, stop talking. And then you have something called intercept form.
Hey, Peters, is this our last chapter before our midterm?
Yes. So your intercept form is A, x minus P, x minus Q, where P and Q are your x-intercepts. So you have three different ways that this can be written. We are going to talk about graphing these quadratic functions. We're also going to talk about how you can find a quadratic, how when you put in inputs like x and y's in your calculator, in your tables, how you can fit a quadratic function to it, like we did with linear functions. Okay. So a lot of things in real life can be modeled by quadratic functions because quadratic functions are what shape? Yes. Yes, a parabola, yes. Parabola. So they go this way or they go this way. So a lot of times the path a ball takes, a bounce that's continuous, ways that roller coasters are built, things like that are parabolas, and they can be used to figure out those type of things in life. Okay, so basic characteristics of parabolas. If you have a parabola that is facing up, you have a vertex, and this has a minimum. Okay, it has a minimum value to it, and that is whatever the vertex is. When it faces down, it has a maximum value to it. And it is also whatever the vertex is. Parabolas are symmetrical, so they have a line of symmetry drawn through the vertex. When you have a parabola that is facing up, okay, a parabola that's facing up, you have a domain of negative infinity to positive infinity, because it would continue to travel on the x-axis forever. It continues to get wider. So you have a domain of negative infinity to positive infinity. But you have a range, okay, let's say that this is 0, 0. You have a range of 0, in this case, to positive infinity. So your range is going to be whatever your lowest point of your vertex is to positive infinity. When your graph faces down, we're going to just pretend that this is 0, 0 again. You have a domain that is 0 to, nope, I lied. You have a domain that is negative infinity to infinity. You have a range, okay, that is negative infinity to 0. So whatever your maximum y value is on your vertex is where you would plug this part in for your range. Okay, so we're going to just practice graphing some of these, sketching these graphs, and then comparing them to the parent function. Your parent function is just simply x squared. F of x equals x squared is my parent function. And your parent function goes from 0, 0 is the vertex. And then if you plug in a 1, you get a 1 out. If you plug in a 2, you get a 4 out because you're squaring it. And that's your parent function of this parabola. So we're going to compare everything to our parent functions. So let's graph a couple things on the same graph. Let's graph g of x equals negative x squared plus 1. And we want to graph and compare to the parent function. Okay. So if I'm going to graph and compare this to the parent function, I need to first of all decide some things that are happening. What do you know looking at this equation that's happening to this original graph? It's facing down, good. What else is happening?
It will.
No, it's not getting skinnier because there's no number besides 1 in front of the x squared.
Vertex 0, 0.
No, the vertex is not 0, 0. It changes. It's going to be 0, because if I plug a 0 into x, I'm going to get, what is my output? 1, right?
So if the x was a number, would it be?
So if there's a number, so here's what it is.
The restroom.
Yes. If you have it in standard form, which is what it technically is in, ax squared plus bx plus c. There is no bx, right? Okay? That's where I get my vertex. My vertex is the opposite of b over 2a is how you find what x is for your vertex. Well, there is no x, so it's 0. Okay? There is no b, so it's 0. So when I plug 0 into this equation, I'm going to get a 1 out. So my vertex of this green equation becomes 0, 1. And I know it's going to face down. So I'm going to graph this. So you will need graph paper tonight. Your parent function looks like this. Okay, so the parent function is this. And so when it says graph and compare, I want them graphed on the same thing, and then I also want a verbal comparison, which we're going to do in a second. My vertex is 0, 1, so here's 0, here's 1. So it shifted 1 unit up on that graph. When I plug in a 1, what I'm going to do is plug in a 1 to this equation, g of x equals negative 1 squared plus 1. So I get negative 1 plus 1, which gives me 0. Yes, so when you plug in a 1, you get a 0 out. All I have to do now is reflect that over this axis of symmetry. And now I can graph it. Okay, so when I compare these in word form, I'm going to say that the function g of x flips and flips down and the vertex shifts up 1 unit. So on your homework, when it asks for you to graph and compare those two, I want you to graph them on the same graph. You can graph them in different colors. And I want you to also write a verbal description of what's happening. Now, on your calculator, you can do these. And here's what you do. You go to y equals, okay? You're going to go into the y1 equals, and you're going to put the parent function, which is just x squared. You press the down arrow to get to the next line, and then you're going to plug in negative x squared plus 1. You're going to press graph. If your window is set in standard form on this one, it will graph it. So negative 10, 10, 1, negative 10. So if you graph it, then you can compare it that way as well. So you can check it that way, make it easier and not have to graph it by hand and plug numbers in. But then that's why I want the verbal description written next to it as well. Any problems on putting that in your graphing calculator? What do you mean still messed up?
Still doesn't want to graph. Like I checked the windows and it's like doesn't want to clear list, so I have to do that manually.
Well, your plots are on, which is gonna be make it. Now it graphs. You just gotta change the window back to standard form.
Which is
Negative 10, 10, 1, negative 10, 10, 1. So we're going to look at one more. And then tomorrow we will finish this lesson. So let's look at comparing and graphing one more. Let's say we have h of x equals, and this time it's going to say x plus 2 squared, and then minus 3. Now, what form is this in? Yes. So if it is in vertex form, that means I can look at this graph and get a vertex out of it without doing any math. Okay. I'm going to go ahead and sketch my parent function again. And I'm going to go 1, 1, 1, 1, 2, 4, 2, 4. Okay, there's my parent function. The parent function never changes. Now, my vertex is what on this graph? If your vertex is the h and k, the opposite of h and then k, what is my vertex? Negative 2, negative 3. So my vertex is negative 2, negative 3. Now I'm going to plug in a number. I would plug in negative 1 or 0. The reason I say negative 1 is because it's right next to it, so it makes it easier to reflect because it's not far away. This is my line of symmetry, right? Okay. So I'm going to plug in negative 1 so that you get h of x equals negative 1 plus 2 squared plus, or minus 3. So negative 1 plus 2 is 1, 1 squared is 1, so 1 minus 3 gives me negative 2. So I have a negative 1, negative 2. Here's negative 1, here's negative 2, I reflect it. Boom, there's my graph. Okay, so how do these compare in written form now? What do I say? Okay, good. So the function h of x shifts 2 units to the left and 3 units down. So that is comparing those functions. Okay. So let's see here. Let's talk about how to identify the vertex of a quadratic function when it's in standard form. If you have an equation that says 2x squared plus 8x plus 7. Okay, y equals, and they want to know what is the vertex. Okay, this is in standard form. When it is in standard form, you have to find the x of the vertex, you have to take the opposite of b over 2a. What is your b? Yeah, 8. So I'm going to take the opposite of it, which is negative 8. So I'm going to say x equals negative 8 over 2. And what's your a? 2. So I get negative 8 over 4, which gives me negative 4. To get the rest of my vertex, I must plug this in. So I'm going to say 2 times negative 4 squared plus 8 times negative 4 plus 7. What's negative 4 squared?
Wouldn't it be negative 2?
Yes, it'd be negative 2. Good call. Okay. What is negative 2 squared? Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16 plus 7. 8 plus 7 is 15, and 15 minus 16 is negative 1. So my vertex is negative 2, negative 1. Your homework tonight is going to include comparing and contrasting graphs and finding the vertex when it's in standard form and in vertex form. We'll talk about how to find it when it's in intercept form tomorrow.